Okay, one more question for determining whether the given vectors are in the vector space or not. So this may be taken as example 3. Okay, so if you have two vectors, u1 is equal to 3 2 and u2 is equal to 5 3, and then determine if it spans if these vectors span R2. Okay, if it is span R2, so that means if they span in R2, so R2 can be now any vector. So if it is R2, that means it will be a vector B which may consist of something like two elements AB. So where AB can be any element. So in this way, then we have to prove that if these two vectors span AB. So it's probably very easy to prove. So for example, we can adopt the same method. Okay, so we can assume that x1 u1 plus x2 u2 is equal to b. Okay, so if we can find the finite values of x1 and x2 in terms of this a and b parameters, so then that means these two vectors span this R2 vector, which is given by something like this AB. So in this case, now it's the matrix form, the augmented matrix form. You can write like this: 3 2 5 3 and A B. Okay, so to make it in to eliminate to apply the Gauss elimination method, so what I can do is I can make this 2 as 0. So by what? So by making like multiplying this first equation by 2 by 3, that will be 2, so it will be minus 2 by 3 the first equation, and then I will add to the so first row, and then I will add to the second row, so that will be the new second row. So in this case, what I get is 3 5 A, and then 2 will become 0 because you see minus 2 by 3 times 3 is minus 2, and minus 2 plus 2, that is 0. And then this will be minus 2 by 3 times 5, this is minus 10 by 3, minus 10 by 3, and then this is 3, so plus 3. So minus 10 by 3 plus 3, it is minus 1 by 3, minus 1 by 3. And then this will be likewise, it will be minus 2 by 3 A plus B. Okay, so this will be the transformed matrix in echelon form. So now we can see that 1 is 1 by 3, x2 is equal to 2 by 3 A plus B. So we can see that we can represent x2 in terms of A and B. So x2 will be equal to minus 2A, and then it will be minus 1 by minus 3B. Okay, so if you multiply it by 3, so it will be minus 3 minus 2A, and then it will be minus B. So it will be minus 2A minus 3B. There is small correction because we multiplied by minus 2, so it will be minus 2 by 3 over here. So it is minus 2, and then it will be plus 2. So 2A minus 3B. So value of x2 is in terms of A and B. And also now we can see that what will be the value of x. So from the from first equation, So 3x1 plus 5x2, x2 is now 2a minus 3b is equal to a. So from here we can find the value of x1 also in terms of a and b. So simplify it. So a, then it is 10a, a minus 10a, it is minus 9a. Okay, a, and then this will be minus 9a, and then minus 9a divided by 3 is minus 3a, so minus 3a, and then it is plus 15b. It will go on the other side, so then divide by 3, so it should be plus 5b. So 2a minus 3b, x1, the value of x1 is minus 3a plus 5b, and the value of x2 is 2a minus 3b. So both a and b are real numbers, so the values of x1 and x2 are also real numbers. So this means that we have finite values of x1 and x2. So it means that it means that these two vectors then span R2. Okay, so where R2 is a set of all vectors having two components, and then we assume these two components are a and b. So we have proved that yes, it spans R2. Okay, so this is our answer. Okay, now okay, another example. Determine if the following vectors span R3. So we need to determine if the following vectors are u1, 2 minus 2, 0, 2 minus 2, 0, and then u2 is 1 minus 1 and 1. Okay, so if these vectors u1 and u2 have to be in a span of R3, so it will mean that we can multiply u1 by some scalars x1, okay, and then u2 by a scalar x2, and then that will be equal to the some vector in R3. So let's say that vector in R3 is represented by A, B, and C. Because it is in R3, the vector in R3 will be having 3 components. Okay, so in this case we can write this in system in the augmented matrix form. So it will be 2, 1, A, and then minus 2, 0, minus 1, 1, B, and C. So this will be the. So now we try to reduce this form into some echelon format. Okay, so what I do is we can do some row operations. We take R1 plus R2, R1 plus R2, that will be new R2. Okay, so we can make this minus 2 as 0. So 2, 1, A, and 2 minus 2 is 0, 1 minus 1 is 0, and then that will be A plus B, and then it is 0, 1, C. So in order to make it in an echelon form, so what we can do is we can interchange the rows R2 and R3. So it is 2, 1, A, and then 0, 1, C, and then 0, 0, A plus B. So in this case, what we can see over here is that in the last from the last row we don't get anything, because we get like 0 is equal to a plus b. So this does not give any value of x1 and x2. So we can get the values of x1 and x2 from the second and third equation. So for example, x2 is equal to c from the second row, and then from the first row we get 2x1 plus x2 is equal to a. So from here we get x1 is equal to a minus x2, which is c, and then divided by 2, so a minus c by 2. So we get the values of x1 and x2 as a minus c and c. So whether these values satisfy this equation, so we can check it from here. So for example, if we input x1 like a minus c by 2, and then it will be u1 was 2 u1 was 2 minus 2 0, and then plus x2, which is c, times u2 was 1 minus 1 minus 1 1. Okay, and then let's try what is, if it is equal to abc or not. So we can see that from here, if you multiply these coefficients and bring it inside, so it will be a minus c, and then it will be c minus a, and that will be 0, and then plus these coefficients plus c minus c, and then c. So what we get over here is a, and then minus a minus a, and then we get c. We get c. So what is this? A and then minus a. What is minus a? Minus a is equal to, because if we take it here is equal to minus a is equal to b. So we get a, b, and c. From this third equation we get minus a is equal to b. So we get a, b, c. So in this case, that means the values which we have determined, which show that we can express this in terms of x1 times u1 plus x2 times u2. So which means that these two vectors are in the span of R3. Okay, so they are in the span of R3. So u1 and u2 are in the span of R3, because the values which we have found, that these values prove that they are in the span of R3. However, if you closely look at this result is not correct. The reason is because in order to make this result as correct, what we have done over here is that we actually got a minus a and c over here, and then we did not find this equal to a, b, c independently, because we have used a relationship something like this over here. 0 is equal to a plus b over here, and then to find this relationship. So it is absolutely not a result that this x1 when multiplied by u1 and then x2 then multiplied by u2 will be always equal to the vector in the R3 space. So therefore our correct answer is that u1 and u2 are not in the span of R3. Okay, they cannot